Hi everyone, I'm Shucheng from Tsinghua University. I will present our recent research on accessibility entitled LightGuide, Directing Visually Impaired People Along a Path Using Light Cues. According to the World Health Organization, approximately 285 million people worldwide are visually impaired. One common myth about visually impaired people is that they cannot see anything, which is not true. In fact, many people who are diagnosed with legal blindness still have some usable vision, such as light perception. For example, in America, 90% of people who are blind have the ability to perceive light. What does this light perception mean? If this is a word in the view of sighted people, then for visually impaired people with very weak light perception, this is approximately what they see. Inspired by this rudimentary light perception possessed by many visually impaired people, we propose LightGuide, a directional feedback solution that indicates a safe direction of travel through the position of a light within the user's visual field. For example, when the user needs to walk straight, the light in the middle of his visual field will be turned on. LightGuide essentially relies on hardware that can emit light from different positions. To prototype LightGuide, we attached a flexible LED strip to the brim of a wearable cap. The strip comprises 45 individually controllable LED pixels. So how does the wearable cap indicate a target direction? We would generate the directional cues based on the difference between the target direction and the user's current direction. For LightGuide to indicate a target direction, the basic idea is simple: to turn on the LED pixel in the corresponding direction. However, the visual conditions of visually impaired people vary from person to person. We therefore propose a set of methods to customize LightGuide to suit different visual conditions. This figure demonstrates how the light changes as the user makes a big turn to his left. To evaluate the effectiveness of LightGuide, we conducted 3 consecutive user studies with 12 visually impaired participants with light perception. Each study aimed to explore users' reaction to light cues when turning to a target direction in place, when following a path, and when navigating in real-world environments, respectively. In all studies, we adopted the same comparison baseline, HapticBag. HapticBag is an on-shoulder haptic feedback solution proposed in a latest related work. Results show that, compared to HapticBag, LightGuide enabled participants to turn to target directions in place more quickly and smoothly with a mean steady-state deviation of less than 4 degrees. Regarding path-following tasks, participants navigated along basic paths and complex paths more efficiently, smoothly, and accurately with LightGuide. LightGuide also helped users to navigate in a real-world indoor environment more safely and efficiently. User subjective feedback implied that LightGuide was easy to learn and intuitive to use. The figure on the right demonstrates users' trajectories when walking along complex paths using both techniques. It can be seen that the trajectories for LightGuide were more convergent to the path center line, indicating a better path-following experience when using LightGuide. This work had 2 main contributions. First, we contribute a novel feedback technique, which utilizes the position of light to indicate a safe direction of travel for visually impaired people with light perception. Second, we developed a set of methods to suit this technique to different visual conditions, and validated the effectiveness of the feedback solution in wayfinding tasks for visually impaired people with light perception. That's all. Thanks for your attention. Please refer to our paper for more details.